me glad. Fair is fair.
Welcome to our tutorial on solving linear equations using inverse operations, an introduction to solving equations by keeping equations balanced. In this lesson, we'll define some key terms that are important to understand before we start actually solving equations. Then we'll look at how to use inverse operations to solve one-step equations. First, we need to define some terms related to equations. Understand that math is a language, just like English. So there are certain rules and structures we need to learn in order to be mathematically literate. An expression is a number of values connected by mathematical operations like addition, subtraction, multiplication, and division. Expressions are like phrases in the English language. An equation is a math sentence that states that two expressions are equal. For example, the expression 3 plus 3 has the same value as the expression 2 times 3. So we can write the equation 3 plus 3 equals 2 times 3 because both sides equal 6. One of the beautiful things about math is that as long as you do exactly the same thing to both sides of an equation, it will always stay equal. We often say that you have to be fair to both sides in order to keep them equal to each other. Or in other words, keep them balanced like a scale. Consider our equation where both sides equal 6. We could add 5 to both sides. We could multiply both sides by 11. And we could even square both sides. The two expressions will still be equal. Instead of equaling 6, they'll just both equal 14,641. Another pair of terms we need to be familiar with is the identity and the inverse. An identity is a number that leaves a value unchanged after performing an operation with it. The additive identity is 0 because if you add 0 to any number, it keeps the same value. The multiplicative identity is 1 because if you multiply any number by 1, it keeps the same value. The inverse is an operation you perform on a number that results in the identity. The additive inverse is the opposite because if you add any number to its opposite, the sum equals 0. Since adding the opposite of a number is the same as subtracting that number, we call addition and subtraction inverse operations. As we can see here, a plus negative a is a minus a, which equals 0. We can see the multiplicative inverse in a similar way. The multiplicative inverse is the reciprocal of a number, because if you multiply any number by its reciprocal, the product equals 1, and 1 is the identity for multiplication. Since multiplying by the reciprocal of a number is the same as dividing by that number, we call multiplication and division inverse operations. As we can see here, x times 1 over x, which is the reciprocal of x, equals x over x, which is 1. Let's illustrate this concept by solving the equation x plus 3 equals 9. Now, logically we can figure out that in order to add 3 to something and get 9, our answer would have to be 6. Once you become more adept at solving equations, performing this step logically is most efficient. But let's look at this more closely so we really understand mathematically why 6 is the answer. First, we can picture the equation like this. Obviously, we have 1x on the left side, and we can let each blue circle represent plus 1 to model the equation x plus 3 equals 9. When solving an equation, we need to get rid of anything that is on the same side of the equation as the x. So in this case, we need to eliminate the plus 3. Since we are adding 3 to x, we use the inverse operation, minus 3, on both sides of the equation. We'll let each of the red circles represent minus 1. Notice that the minus 3 cancels out the plus 3 on the left side. But it also cancels out 3 of the 9 that are on the right side. This gives us our result, x equals 6. For our final example, we'll solve the equation 4x equals 12. Now, logically, we can figure out that in order to multiply something by 4 and get 12, our answer would have to be 3. But again, let's look at it more closely so we really understand mathematically why 3 is the answer. First, we can picture the equation like this. We see 4 x's on the left side, and we see 12 on the right side of the equation. In this case, we need to eliminate the times 4. So since we're multiplying x by 4, we use the inverse operation, divided by 4, on both sides of the equation. Division breaks things into even groups. So you can see that when we break each side into 4 groups, there is 1 x in each group on the left side, and a 3 in each group on the right side. Since each of these groups is equal to the others, we can reduce both sides to get our solution, x equals 3. Being able to solve one-step equations like this is really the first step to understanding how to solve more complex equations. Take some time now to practice, making sure not just to use logic, but to identify the inverse operations you are using each time.